looking at 2.2b, graphing slope-intercept form. Remember, slope-intercept form is y equals mx plus b. We want to be able to identify the slope and y-intercept from an equation or a graph. We're going to look at graphing linear equations. Remember, linear means they're straight lines. And then we want to be able to look at a graph and write down the equation for that line. Just a little bit of review to start off. So remember, our y-intercept, that's the point where our graph crosses the y-axis. If it's crossing the y-axis, we know that the x value is 0. So we know that our y-intercept is the point 0, b, 0, and then the y value. When we're looking at our slope, that's our rate of change. We have a few different kinds. Positive, where it's increasing, negative, where it's decreasing, 0, where our slope, m is equal to 0, that's a horizontal line, and undefined, where we don't have an m, that is a vertical line. Okay, then we also talked about using our rise over run. So our slope is equal to our rise over our run. So if we're looking at how far our rise is, that's how far up or down we're moving to get to the next point. Our run is how far over, in other words, how far to the right we're moving to get to the next point. If we have 2 points, we can use our m equals y2 minus y1 divided by x2 minus x1 in order to find our slope. We're going to start off by looking at an equation in that slope-intercept form and graphing it. So we're looking at y equals negative 1/3 x plus 4. Well, in order to graph this, we need to figure out what our slope is and what our y-intercept is. We practiced this yesterday. Our slope is whatever is being multiplied by x. So that is our negative 1/3. Our y-intercept, that's our plus b. Well, we are adding 4. So our y-intercept is a positive 4. Now that we have this, we're going to use it to graph our line. Well, we need a point. So we are going to use our y-intercept to find a point on our graph. Remember, if b equals 4, that means our y-intercept is the point 0, 4 by definition. So let's graph 0, 4. Well, our slope we know represents our rise over our run. So to get to another point on this line, we are going to go down 1 and over 3. Down 1 and over 3. Down 1 and over 3. You need at least 2 points to graph a line. I like to write in as many points as I can just for accuracy. If I want to graph things to the left of my y-intercept, I'm going to do the opposite of my rise over run. So if I was going down 1 over 3, the opposite would be to go up 1 and back 3. Up 1 and back 3. Up 1 and back 3. When you have all your points, now all you need to do is connect them. So we just need to draw a line through these points. This is our graph for y equals negative 1/3 x plus 4. Let's look at another one. Y equals 2x minus 4. So we are going through the same process. We're going to find our slope. Well, 2 times x, m is equal to 2. Notice how for our b, this time we are subtracting 4. Since we are subtracting 4, our y-intercept is going to be negative 4. Well, now that we have that information, we know a point on this graph is the point 0, negative 4. So let's graph that. 0, negative 4. Now, 2 isn't a fraction, but the number 2 is the same as 2 over 1. So I can just turn that whole number into a fraction. And now I have my rise of 2 and my run of 1. So to find other points, we are going to go up 2 and over 1. Up 2 over 1. Again, you need at least 2 points. I like to draw in more than that just for accuracy. And to do the opposite to get everything to the left of your y-intercept. So that would be down 2, back 1. Down 2, back 1. Notice how my points are going to make a nice straight line when I connect them. Going to try that again, a nice straight line when I connect them. I suggest using a ruler, the side of a folder, something so you can make that nice straight line as you're going through this. Now, sometimes we're given an equation, but it's not in slope-intercept form. Like if we're given 2x plus 3y equals 12. That's not in slope-intercept form, but from Unit 1, we know how to rearrange it and put it into slope-intercept form. So if I want it to look like y equals mx plus b, I'm going to solve this equation for y. Well, to get y by itself, just to keep in mind we're trying to get y by itself, I'm going to subtract 2x from both sides. Right, so then on my left-hand side, I have 3y equals negative 2x plus 12. Well, we're almost done, but the opposite of 3 times y is dividing every term by 3. So our slope-intercept form is y equals negative 2/3 x plus 4. This is our slope-intercept form. And when we have our slope-intercept form, well, whatever's being multiplied by x is our slope, negative 2/3. Whatever we're adding at the end is our y-intercept. Now this second problem, we'll call this letter B. Y equals 10 minus x divided by 5. This one we just need to tweak a little bit in order to have it look like that slope-intercept form. So instead of having the quantity 10 minus x divided by 5, I'm going to split this up. And I'm going to say, well, I want to take 10 divided by 5, and I want to take x divided by 5. From here, I can simplify. Well, 10 divided by 5 is 2. Negative x divided by 5, I can actually rewrite as subtracting 1/5 times x. So I just pulled that x and that divided by 5 apart. To get it completely in that slope-intercept form, I'm just going to switch around my 2 and my negative 1/5 x in order to have y equals negative 1/5 x plus 4. And we have slope-intercept form. So if we're looking at this, well, m is negative 1/5, and b, our y-intercept, is 2. So occasionally we'll need to tweak or rearrange our equation slightly in order to put it in that slope-intercept form. Here's a special case. So if we have y equal to some number, remember this is like saying we have y equal to 0 times x minus 7. Okay, so if you have y equal to some number, that means you have the slope of 0. And we want to start recognizing that pattern. If our slope is 0, that means we're going to have a horizontal line. A horizontal line where our y value is always going to be negative 7. So I'm going to find negative 7 on my y-axis, way down here. Okay, well, then I'm just going to draw a line right there. A line going through that point, a horizontal line to be specific. And that is our graph for y equals negative 7. Notice if we look at a couple of points on this line, well, this first one is the point 0, negative 7. Way over here, we have the point 4, negative 7, the point 8, negative 7, the point negative 2, negative 7. So those x values are changing, but on that line, y is always going to be negative 7. So y is always going to equal negative 7. We also have that special case where we have x equal to some number. So notice how there's no place for our m. This is our undefined slope. Undefined slope. We want to start recognizing that this means we're going to have a vertical line. A vertical line where x is always equal to 2. So I'm going to find 2 on my x-axis. And then I just want to draw a vertical line passing through that point. And that is our graph, x equals 2. Again, if we look at a couple of points on this line, Well, we have 2, 0, we have 2, 3, we have 2, -3. That x value is staying constant. If we want to graph y equals 1/2 x, so again, a little bit different. In this one, we don't have a b value. So basically, we're adding 0. So this is telling us that m is equal to 1/2, because we have 1/2 times x for our slope, and our y-intercept is equal to 0. Well, that tells us that we have the point 0, 0, which is the origin, and from there, we're just using our rise over our run. Up 1 over 2, up 1 over 2, up 1 over 2. And then we can go ahead and we can connect all of our dots. Remember, you want to do a nice straight line when you're doing this for accuracy. That was a horrible example of a nice straight line. Here is a nice straight line passing through those points. Just to recap, you find your slope and your y-intercept. So slope would be 3/4, y-intercept would be 5. You graph your y-intercept, the point 0, 5, and then you use your rise over run. So up 3 over 4. You use that rise over run in order to graph the rest of your points. Once you have at least 2 points, you just connect them, and that is all you need. That is your graph. So, looking at a couple of reminders, this formula, y2 minus y1 divided by x2 minus x1, that's something you want to start memorizing, as is the fact that slope is the same as rise over run.